Hello students, how are you? I am Manu sir from AEP. Today I will continue square and square roots chapter. So today first I will discuss these points. First point is recapitulation of squares. That means in the last class what I have discussed, that portion again I will discuss briefly. Second point is how to find the given number is perfect square or not. Third point, square root of a number. Fourth point, finding square root of a perfect square number by repeated subtraction method. And fifth point, finding square root of a perfect square number by prime factorization methods. So these 5 points one by one I will discuss now. Is it clear? Now first point is recapitulation of squares. That means in the last class what I have discussed briefly I will discuss now. The square of a number a, what, equals to a into a, that is a square. Yes, we have learned it. Now unit digit of square of a number, that means if we take square of any number, then unit digit will be 0, 1, 4, 5, 6 or 9. But never 2, 3, 7, 8. Yes, please try to remember, we have learned it. Now any number ending with odd number of zeros cannot be perfect square. Definitely we can say the number ending with odd number of zeros is not perfect square. Yes, the sum of first n odd natural numbers equal to n square. That means if we add first 10 natural number, then what will be the sum? First 10 odd natural number if we add, then the sum will be 10 square, that is 100. Yes, so these points already we have discussed in the last class. So now I will discuss the second point. So first point is discussed now. How to find the given number is perfect square or not. The second point I am going to discuss now. How to find the given number is perfect square or not. Step 1, check the unit digit of the given number. If it is 2, 3, 7 or 8, then it is definitely not perfect square. Is it clear? Now step 2, check whether the given number is ending with odd number of zeros. If yes, then it is definitely not perfect square. This part is clear? Now step 3, if step 1 and step 2 fails, then express the given number as product of prime factors. If all the factors are paired, then the number is perfect square, otherwise it is not perfect square. This part is clear? So first, when we are going to check the given number is perfect square or not, first we will check the unit digit of the given number. If the unit digit of the given number is 2, 3, 7 or 8, then no need to do anything. We can say definitely this is not perfect square. If we see the given number is ending with odd number of zeros, then also no need to do anything. Definitely we can say this number is not perfect square. But if these two cases not occur, then we will proceed for step 3. That means we will express the given number as the product of prime factors, and if we see all the prime factors are paired, then we can say the number is perfect square. This part is clear? Now we will discuss one example. Check whether the following numbers are perfect squares. Here 4 numbers are given. We have to check which one is perfect square and which one is not perfect square. So one by one I'll do. The first number is 44100. 44100. So first we are seeing here the number is ending with 2 zeros, that is even number of zeros. So that means the number may be perfect square, maybe. So now if we see the other digit, that is 441, we know 441 is perfect square because 21 square is 441. So that means the whole number is perfect squares. Yes, this number is perfect squares. Is it clear? So this number we can write 210 whole square. So that means this number is perfect square. Now the second number is 2378. See, the unit digit of this number is 8. So obviously it is not perfect squares. Without any hesitation we can say it is not perfect square. See the third number 67800. Again see, this number is ending with odd number of zeros. So definitely we can say this number is not perfect square. Now the fourth one, 10584. 10584. Here unit digit is 4. That implies this number may be perfect square. So in this case we have to find out the prime factors. So find out 10584. So obviously this number is divisible by 2. 2 5 10, 2 to the 4, 2 9 18 and 2. Again we can give 2, 26, then 2 4 8, 2 6 12. Again 2, 3 2 and 3. Now this number is divisible by 3. 3 plus 2 5 plus 3 8 plus 1 9. Sum of digits is 9. That will be divisible by 3. 3 4 12, 3 4 12 and 3 1. Now again 3. 3 1, 3 4 and 3 7. Now 7, or we can give 3 again. That's a 7, we can give 7 2 7 1, again 3 7. So what are the prime factors? 2, then 3, how many times? 3 times, and 7 2 times. Clear? So now if we make the pair, see all the prime factors are not paired. 1, 2 is not paired, here 1, 3 is not paired. Since all the prime factors are not paired, therefore it is not perfect square. Therefore it is not perfect square. This number is not perfect square. I think this part is clear? Okay. Now see example number 2. Find the least number by which this 106722 should be multiplied to make it perfect square. That means this number is not perfect square. Which least number you have to multiply to make it perfect square? Is it clear? So how can you solve it? To solve it, we have to find out the prime factors of the given number. So do it. 106722. So 2, 2, 5, 10, 2, 3, 6, 36 and 1. Now it is divided by 3. Check it. 7, 10, 13, 18. Yes. 3, 1, 3, 7, 3, 7, 3, 8 and 3, 7. Now again 15, 22, 29, 30. That is again divided by 3. 3, 5, 15, 3, 9, 27 and 2, 9. Yes. Again 9 plus 2, 11, 9, 20 plus. This is not divided by 3. So now check the next prime number. 5 is not, because 9 is in the unit place. So now check by 7. 7, 8 the 56, 3, 32, 7, 4, 28, 4, 49, 7. Yes, this is by 7. So 7, 8 the 56, 7, 4, 28 and 7, 7 the 49. Again divided by 7, 12 and here 1. Now it is divided by 11. So 106722, this number 2 into 3 into 3 into 7 into 7 into 11 into 11. So if we make the pair like this, so what we are seeing here, 2 is not paired. All other prime factors are paired, but 2 is alone, is lone factor. So to make it perfect square, we need one more 2. That is the least number. So minimum we want one more 2 to make it perfect square. Yes or no? Because if I take 1, 2, then it will be paired. Yes or no? So here the least number equal to 2. So 2 will be the answer. I think this part is clear. Now example 3. Example 3 is find the least number by which 24500 should be divided to make it perfect square. In the previous one, least number by which the given numbers will be multiplied, but here we have to find out the least number by which the given number should be divided to make it perfect square. So we will follow the same process. That means we will find out the prime factors of the given number. So 24500 divide by 2, 1 2 2 5 0, again 2 6 1 2, yes, and 5. Now we can give 5, 12 2 and 5. Again we can give 5, 5 2, so 5 4 and 5. Again 5, 5 4 5 9, yes. Now 7 7 49 and 7 1. So that means 24500, this number we can express as the product of prime factors like this: 2 into 2, 5 into 5 into 5 into 7 into 7. Yes. So if we make the pair, see here, 5 is the lone factor. That means this 5 is not pairing. It's not possible to pair this 5. So obviously 5 is the least number by which the given number should be divided to make it perfect square. Yes or no? So here the answer, the least number equal to 5. This is the answer. Yes. So example 3 completed here. So now I'll discuss the next point. How to find the given number is perfect square or not, that part already discussed. Now I'll discuss the third point, square root of a number. Square root of a number, this part I'll discuss. This is a very important part. How can you find the square root of a number? Or what is the concept of square root of a number? A square root of a non-negative number, be careful here, non-negative number. That means whose square root we have to find out, the number should be non-negative. It cannot be negative. Yes. So we will find the square root of a non-negative number, and the square root of non-negative number is that value when it is multiplied by itself produces the original number. That means if x is a non-negative number and if we consider square root of that number, that is square root of x, be y, then square root of x is y. That means x equals to y into y. X equals to y into y, that is y square. So here this symbol is known as radical sign, and the x, that means whose square root we are finding, that x is called radicand. This part is clear? But remember, square root of x square is not x only, because square root of x square, x when x is greater than equals to 0, but it will be minus x when x less than 0. Clear? Because square root of any non-negative number is always positive. So why I wrote two cases here? Because x greater than equals to 0 means positive and 0, but here x less than 0. Say square root of 4 square, so 4. But if I ask what is the square root of minus 4 square, so since here x is minus 4, that is negative, so the result should be minus x. So minus of minus 4, that is plus 4. Yes. So if I write only x, always if we write x, then answer will be wrong, because in case of minus 4 whole square, then minus 4 result, but that is wrong. So that's why we have to consider two cases. When x greater than equals to 0, then x, but when x less than 0, we will write minus x. I think this part is clear. Okay. See, so according to definition of square root number, what? Say square root of 25. What? I write 5. Why 5? Because if we multiply 5 two times, then we are getting back the original number. Yes or no? That I told in the square root of a non-negative number is that value when it is multiplied by itself produces the original number. Is it clear? So root over 25 equal to 5. Why 5? Because 5 is multiplied by itself is giving the original number. Yes or no? Now one more example. Say square root of minus 12 square. Square root of minus 12 square, first we will write it is 12 square, because negative square value is positive only, that is 12. But anyone can write directly this minus or minus 12, that is plus 12, because I gave the definition, if x is negative, then square root of x square is minus x. Clear? So directly also we can write like this. I think this part is clear. Now the fourth point, so third point is clear. Fourth point, finding square root of a perfect square number by repeated subtraction method. I'll discuss the fourth point, finding square root of a perfect square number by repeated subtraction method. Okay, so here finding square root of a perfect square number by prime factorization method, not sorry, repeated subtraction method, finding the square root of a number by perfect square number by repeated subtraction method. So step 1 for this, subtract 1 from the given number. Step 2, subtract 3 from the number obtained in step 1. Step 3, subtract 5 from the number obtained in step 2. Like this, subtract odd natural numbers successively until the result is 0. Yes? When the result is 0, then stop the process and count how many odd natural numbers are subtracted. If n odd natural numbers are subtracted, then square root of the given number will be n. So this is the process. So basically what? Very simple thing. First we will subtract 1 from the given number, that is first odd natural number. Then from that result we will subtract second odd natural number 3. From that result again we will subtract next odd natural number, that is 5. And in this way we will continue until we are getting result 0. When we are getting 0 result, then we'll stop and we'll count how many odd natural numbers are subtracted from the given number to get 0. If n odd natural numbers are subtracted, then the square root of the given number will be n only. Is it clear? So it will be more clear if I discuss one sum. So example number 4, find the square root of 49 by repeated subtraction method. We have to find the square root of 49 by repeated subtraction method. So we know the result will be 7. Square root of 49, we know the result will be 7, but see how by repeated subtraction method the result is 7 coming. So what I told just now, subtract, step 1, subtract the first odd natural number, that is 1. So you are getting 48. Then subtract 3, 45. Then subtract 5, 40. Then subtract 7, that means 33. Then subtract 9, that is 24. Then subtract 11, so 13, and then subtract 13, 0. So we got 0 here. So now I'll count how many odd natural numbers subtracted. 1, 2, 3, 4, 5, 6, 7. Since 7 odd natural numbers are subtracted, therefore square root of 49 will be 7. I think this part is clear. So by repeated subtraction method, we can find the square root of a given number. Is it clear? So now I'll discuss the next point, that is 5th point. 4th point completed. Now 5th point, finding square root of a perfect square number by prime factorization method. This is a very important method. Basically, we will apply this method to solve many sums. Is it clear? Finding square root of a perfect square number by prime factorization method. Step 1, express the given number as the product of prime factors only. Step 2, group identical factors into pairs. Step 3, take one factor from each pair and multiply them. The result obtained is the square root value of the given number. So these are the steps to find the square root of a perfect square number by prime factorization method. Is it clear? So what we have to do? First, the given number we have to factorize. We have to find out the prime factors. We have to express the given number as a product of prime factors. We will make the pair, we will group the identical factors into pairs, and now take one factor from each pair and multiply them. The result obtained will be the square root of the given number. So now take one example, it will be more clear. Find the square root of 1225 by prime factorization method. 1225. So find out the prime factors of this number. Obviously it is divided by 5, 5 to 10, 5 4 20, 5 5 25. Again 5, 5 4 20, 5 9 the 45. Now 7. So 5 into 5 into 7 into 7. 4 prime factors, and we are making a group of identical prime factors in pair form, that is 5 into 5 one pair and 7 into 7 one pair. Therefore, square root of 1225, 5 from this pair into 7 from this pair, because 1 factor from each pair, so that means 35 is the final result. Clear? Now example 6. Find the square root of 53361 by prime factorization method. So one more sum we'll do applying this method. So you have to find out the square root of this number. For that, we'll find out the prime factors of this number. Obviously, this number is not divisible by 2. Is it possible by 3? Check it. 7, 10, 13, 5, 18. So divisible by 3. 3, 1, 3, 7, 21, 3, 7, 21, 3, 8, 24, 3, 7. Again check. 15, 22, 29, 30. That means divisible by 3. 3, 5, 15, 3, 9, 27 and 29. Again check it. 11, 9, 20, 25. That is not divisible by 3. Now check it. 7, 7, 8 the 56. Yes. 7, 8 the 56. 32, 7, 4 the 28. 7, 7 the 49. Again 7, 12, 1. Now 11. So 3, 3, 7, 7, 11, 11. Is it clear? So now group of identical factors. Therefore, square root of 53361, we are getting 3 from this pair, 7 from this pair, 11 from this pair. That is 21 into 11, 11, 1, 11, 1 carry, 22 plus 1, 23. So 231 is the square root result. Is it clear? Now the last examples, example number 7. Check whether 47 is perfect square by repeated subtraction method. So you have to check 47 is perfect square or not by repeated subtraction method. Is it clear? So we'll follow the repeated subtraction method. 47 minus 1. This is minus 1. Clear? So 47 minus 1 is how much? 46. Now subtract 3, 43 minus 5, that is 38, minus 7, 31 minus 9, 22. Then minus 11, that is 11, and 11 minus 13, that is minus 2. Since negative number came, that means there is no chance to get 0, because already negative number we got. Since result 0 is not possible, so that's why this number is not perfect square. So 47 is not perfect square. Is it clear? Not perfect square, because never will get 0. By repeated subtraction method, we never will get 0 here. That's why it is not perfect square. I think this part is clear. Yes, student? So I am ending here, but if you have any more queries, you can contact me through my mail ID manojj@tigps.in. And one more request, please watch my next video to get more interesting sums. Thank you students. Bye bye students.